Hello there. This is Unit 8, Day 2. We're graphing exponential and logarithmic functions and also natural log functions. So exponential functions are functions where the variable, usually x, is in the exponent. That's why they're called exponential functions. A, B, and C, those are exponential functions. If you'll notice for those three, the variable x is in the exponent. So D, E, and F, those are called logarithmic functions. That word log is for short. It's short for log. These all happen to be base 10, which is good. Those are the easiest ones to learn. But they're all going to be pretty easy because you can change the base really easily on your calculator. So if you see a 10 there, it's obviously 10. However, if you just see the word log but no number following in that little subscript, then it's also going to be 10. On your calculator, if you were going to graph letter D, for example, you could do it one of two ways. You could type in the word, you'd go to y equals and then hit that log button. When no little number pops up after that G, that's assuming that the log is 10. So when you're doing D, if you just type in X and then close that and then graph it, that'll be fine. However, it would be helpful also to know when when the base is not 10, how you can do that on your calculator. If you go to, you still want to be in y equals, but if you go to math and then you're going to go down and you're going to see, so I just realized that the calculator that I'm using on the computer doesn't have it, but yours is a better calculator and it has it. So when you go to y equals and you want to see log base, you're going to hit math, and then you're going to arrow down all the way to where you see the letter A, and you should see log base. You're going to hit enter, and you'll see a little blinking dot there, a little cursor. You can put whatever number you want into there. Now, if it says 10, you want to put 10, and then there's another spot to put everything in the parentheses and outside of the parentheses. So they've really made it easy for you on the calculator. Also, if we look at the exponential function, which is c, h of x equals e to the x. E is like the second most well-known irrational number. E is the base of a natural logarithm, and it's equal to like 2.72. You know how pi is 3.14? Well, E is about 2.72. It's an irrational number, so it keeps going and going. But there's a button for that on your calculator also. So when you guys are doing C, go to y equals, and see this ln? That actually stands for natural log. Well, look above it, and there's e to the x. So if you're in y equals, and you wanted to graph C, which is h of x equals e to the x, you're going to hit second, and then this ln button, you're going to see that e, and you're going to raise it to the x, and then you're going to hit graph. So go ahead and match the graphs to the equations, and then we'll get into the short bit of notes. All right, keep up the good work. What are you waiting for? Go ahead and graph. Come on. Hit pause and graph. Still there? Hit pause and graph. And raise your hand if you need any help. Alright, so hopefully you graph those and then just skip ahead. So now here we are. We're writing down your observations of the graphs of exponential and logarithmic functions. Things you might notice about exponential functions are that there's exponential growth. In other words, they're increasing really fast. And then they flatten out to a horizontal line, and they have a y-intercept of 0, 1. That may change, but for what we've seen, yeah, they had the y-intercept 0, 1. Logarithmic functions, on the other hand, they are slowly increasing, and they flatten out to a vertical line. So we're going to learn about asymptotes and where things flatten out. It's a funny word, but they're very important to know about when we're talking about exponential functions and logarithmic functions. We'll talk about those later. So, we want you to graph this exponential function, y equals 2 raised to the x. You can make a table here, or you could just go to y equals and do 2 to the x, and you'll see like when x is -2, y is 1/4, for example. And it's important to be accurate with your graphs. But you see this green line here? Hopefully you do. That's called a horizontal asymptote. Okay? It's a line that your function is approaching but never quite touching. So with exponential functions, they're going to have horizontal asymptotes beginning with y equals. Remember, horizontal lines have they begin y equals, and they're, it's y equals a constant. You don't see any x's or anything. So for this function, its horizontal asymptote is y equals 0. So what that means is this function is never going to go, is that never actually going to reach 0. It's going to get closer and closer to 0, and it's never going to go below that line y equals 0. It's going to go up and up and up and up, but it never gets any lower than, or never actually even reaches y equals 0. Okay? The x-intercept, therefore, doesn't exist because it doesn't reach the point where y is equal to 0. It gets very close to it, but it doesn't reach it. And then you'll see that when x is 0, y is 1, so therefore it crosses the y-axis at the point 0, 1. So the y-intercept is 0, 1. This thing is always increasing from left to right, if you look at it from left to right. And that's the gist of exponential functions. There's an a, an h, and a k. This shows you where the a, h, and k are. A, h, and k, they do similar things. H shifts it left and right. K shifts it up and down and so forth. And let's look at the next thing. Here you have a logarithmic function. Hopefully you're noticing the differences. This log function has an x-intercept at the point 1, 0. What does it not have? It doesn't have a y-intercept. So it's the asymptote here is a vertical asymptote. It's here in blue, and it's x equals 0. So this never goes any further left than 0, and again, it's an asymptote, so it never actually reaches 0. So it does not have a y-intercept. Okay? It does increase, not as fast as an exponential function, but yes, it does increase from left to right. Okay? Here's a table that you could also get on your calculator. Just for the example, we did g of x equals log base 2 of x. So you might need help doing that on your calculator, and we can show you how to do that. And I can show you how to do it right here. Again, y equals, oh yeah, my calculator doesn't have it, so you're going to have to raise your hand if you want us to do that. Sorry about that. But we'll show you how to do the change of base thing, if you didn't remember already. Here's some more examples. Go ahead and do these, and pay attention to how they shift. When they shift, those are transformations. And you're going to, sometimes have to be able to identify transformations. So know the difference between exponential functions and log functions. Know how to graph them on your calculator. Know how to identify asymptotes. And you should be good to go. All right, so just ask for help if you need any, and we'll move on to practice problems.